The earliest attempts to build enterprise AI shared a common flaw. Teams treated every new business capability as an entirely standalone agent. To stand up a single new capability, developers had to assemble orchestration logic, configure memory architectures, and wire up telemetry from scratch, over and over again. Across an enterprise, this duplication causes systems to degrade. Conversational context splinters across isolated databases, and compliance guardrails vary significantly from one department to the next. The breaking point comes during execution. To resolve a multi-step user request, these isolated agents are forced into brittle handoffs, passing session state back and forth just to maintain context. The Agentic Intelligence Framework, or AF, corrects this structural flaw. The architecture replaces the individual agent with a broader runtime boundary called the context engine. Inside this boundary, business capabilities are no longer distinct isolated entities. They operate as governed workflows, sharing a unified hub. By adopting this model, platform teams supply all the underlying orchestration, memory, and telemetry, freeing domain experts to focus on defining business intents and APIs. To secure these workflows at scale, the framework operates within a strictly defined ecosystem. AIF does not execute in a vacuum. At the base of this architecture is the model layer, housing the interchangeable foundation models that generate responses. Sitting directly above those models is Nexus OS, the enterprise AI control plane. This middle layer enforces mandatory infrastructure governance. It intercepts every single API call to log PHI audit trails and block prompt injections at the gateway level, enforcing security controls independent of application code. Finally, the AIF application layer locks in at the top. This is where workflow logic and conversational memory live. This separation creates defense in depth. Nexus OS operates on the token stream. It cannot parse whether a conversation contains a healthcare crisis signal. AIF understands the healthcare context, but it sits too high to enforce network-level security. Securing enterprise AI requires both surfaces. Because Nexus OS abstracts the underlying foundation models, engineering teams gain model agnosticism. Switching workflows from older to newer models requires zero code changes within AIF. Isolating infrastructure governance from domain logic allows organizations to enforce mandatory security while maintaining the speed of their AI deployments. To see how those deployments actually run, we look at the top application layer to examine the internal anatomy of the context engine. The process begins at design time in an authoring interface called the Routine Builder. Teams draft their workflows here and submit them through a strict approval lifecycle. Once published, the system handles complex requests. Take a user asking for a pharmacy refill and potential drug interactions. The prompt hits intent detection, which splits the single request into parallel workflow paths. Those paths feed the graph compiler, translating published logic into executable graph plans. The graph executor takes over, running compiled blueprints simultaneously and managing tool calls before joining results into one coherent response. Throughout this execution, no agents had to hand off context to one another. That is because a centralized state manager tracks the active steps and branching decisions for every workflow in flight. Alongside it, the context manager hydrates the workflows using platform-provisioned memory, relying on Redis for short-term session data and Postgres for long-term historical continuity. Centralizing orchestration in the graph and memory in the managers removes the brittle practice of passing state between separate agents. Scaling this system means enabling domain teams to add specific capabilities to their workflows without hard-coding custom integrations. This is managed through the Asset Store, a centralized catalog of approved enterprise building blocks. Teams can browse this library and snap pre-built routine, specialized, or utility agents directly into their workflows to handle common tasks or back-end API connections. Standardizing components addresses integration, but it does not account for long-term reliability. Historically, teams would deploy these systems and add quality measurement as a manual, post-launch afterthought. AIF treats evaluation as a first-class architectural primitive, built directly into runtime execution. As the graph executor outputs responses, data streams into an observability pipeline, enabling automated AIF as judge scoring and real-time live traffic sampling. For more rigorous verification, a dedicated batch evaluation pipeline tests complex workflows against SME-curated golden datasets to prevent regression. Coupling a governed library of reusable assets with continuous embedded runtime evaluation ensures that interactions behave consistently across the enterprise. When we view the entire ecosystem, the distinction between domain logic and shared infrastructure becomes clear. The developer experience is streamlined. Engineering teams no longer build memory architectures or gateway authentication protocols. They simply deploy a new context engine instance. They hydrate that instance by injecting their specific domain roles, provider contexts, and approved APIs. They define their business intents in the routine builder, clear the approval checks, and hit publish. This operational model cuts off agent sprawl at the root. By centralizing memory, orchestrating through structured graph execution, and embedding continuous evaluation, AIF delivers a reproducible, secure, and scalable foundation for enterprise intelligence.